Hi guys, so this is Princess B. Pangcatan. Welcome to my video. I'll be talking about molarity, freezing point depression, and calorimetry in a very short manner. And I'll be giving an example for those three, just one example. So please stick with me. Thank you. Molarity. It is the amount of substance in a certain volume of solution. We can solve molarity using this formula. M is equal to moles of solute over liters of solution. Here's a sample problem for molarity. Calculate the molarity for 0.444 mole of COCl2 in 0.654 liters of solution. First, we list the given, which is the moles of solute, 0.444 mole of COCl2, and the liters of solution, which is 0.654 liter of solution. Using the formula given in the previous slide, we divide 0.444 mole of COCl2 over 0.654 liters of solution. And now we get 0.679 m. Moving on to freezing point depression. It is a colligative property observed in solutions that results from the introduction of solute molecules to a solvent. We can solve freezing point depression using this formula. Change in temperature is equal to I Kf(m), whereas I is the Van 't Hoff factor, Kf the molal freezing point depression, and m the molality, which can also be expressed as moles of solute over kilogram of solvent. Here's a sample problem for freezing point depression. What is the freezing point of a solution prepared by adding 140 grams of trichothecene to 0.746 kilograms of benzene? The freezing point of pure benzene is 5.5 degrees Celsius, and the freezing point constant for benzene is 5.12. So before we list down the given items, we have to convert the grams into mole, which is why we have 140 grams is equal to 0.421192 mole. I assume that all of us have already learned the conversion factor when dealing with chemical equations. So we move to list down 5.12 as the freezing point constant, which is Kf. Using the formula mentioned in the previous slide, we write 1 as the Van 't Hoff factor because we are dealing with non-electrolytes here, multiplied to 5.12 degrees Celsius times kilogram over mole, multiplied to the molality, which can be expressed as 0.421192 mole over 0.746 kilogram. We cancel the similar quantity values. Now we get 2.89 degrees Celsius as the amount of freezing point depression. To solve for the new freezing point, we subtract the freezing point of the pure substance, the pure benzene, which is 5.5 degrees Celsius, to the amount of freezing point depression that we got earlier, which is 2.89 degrees Celsius. Thus, we get 2.6 degrees Celsius as the new freezing point and the answer to the problem. Now we proceed to calorimetry. It is the act of measuring different changes in the state variables of a body for deriving the heat transfer related to the changes of its states. We can solve this using this formula. Q sub is equal to m times C times change in temperature, whereas m refers to mass, C refers to specific heat, and change in temperature. Moving on to the sample problem for calorimetry. A piece of iron with a mass of 7.89 grams undergoes a temperature change from 24.5 degrees Celsius to 48.9 degrees Celsius. How much heat was absorbed by the iron? So first we list down the given items, which is mass is equal to 7.89 grams, and then we solve for the change in temperature through subtracting the final temperature to its initial temperature, which we get is 24.4 degrees Celsius as the change in temperature. As you can see, there was no specific heat capacity mentioned in the problem, but since iron was mentioned, we can use its specific heat capacity, which is 0.444 joules per grams times degrees Celsius. Using the formula mentioned in the previous slide, we write 7.89 grams multiplied to 0.444 joules per grams times degrees Celsius multiplied to 24.4 degrees Celsius, and then we cancel similar quantity values, and then we multiply them, thus we get 85.5 joules. Thus, the answer to the problem is positive 85.5 joules since heat was being absorbed by the iron. Hi guys, we're finally finished. Thank you for watching this video. Again, my name is Princess Honeybee Pangcatan from STEM 12 to Chemists. Don't forget to like and subscribe to this channel. And before we end this video, Happy New Year, and I hope that 2021 will be a good year for all of us. Thank you and bye-bye.